So let's dive deeper into measurement system analysis. So there are two types of variation that we see. Okay. One is called as, there is a variation in the process itself. I mean, even any process that you take, there is a variation. Let's say, prepare a cup of coffee. Okay. If I'm going to measure the quantity of coffee that I've prepared, there is going to be a variation. If I'm going to measure the temperature of the coffee, there's going to be a variation. So by inherent nature of the process, I cannot have any process without variation. Pizza. The diameter of pizza also has a variation. At the same time, suppose if I measure the, say, sugar level, that measurement process also has a variation. The process itself might have, because my sugar level itself does have a variation from time to time. At the same time, the measurement system can also cause the variation. For example, if I'm 60 kgs in weight, for example, the measurement system might show 60.1. Because the measurement system has got that sort of a variation. Okay. Now going deeper, we have spoken about a measurement system can have an accuracy and a precision. Measurement variation can be classified as accuracy and precision. We have explained accuracy and precision in the earlier slides. Now we are going to get into what is called as repeatability and reproducibility. Let me give an overview of repeatability and reproducibility. Suppose if I throw the ball and it goes through a particular distance, if I throw 10 times, how much repeatable can I to cover the same distance of the ball? Okay, repeatability. How consistently I can repeat. For example, some bowlers will consistently bowl in the same dot, same point, right? Which is the classic bowler. Let's have some good engagement here. Like, he exactly bowls in the same spot. Maybe Bumrah, right? So that is called repeatability. Suppose if you ask 2 or 3 bowlers to bowl in the same spot, suppose if you mark a circle and bowl in the same spot, maybe we may not be able to reproduce it, or they may be able to reproduce it. So repeatability and reproducibility is important. The other, so that is on the bowling front. Suppose if I have a pen and the diameter, I measure this. Suppose if I measure this 10 times, do you think I will get the same reading? Yes or no? The same pen, same park, I measure 10 times. Do you think all the 10 readings will be the same? No. It can vary, right? So that is called as a repeatability variation. Suppose I measure this pen and I note the diameter of this pen, and you measure this pen and note the diameter. Do you think both the readings will be same? Same measuring instrument, same park. Only the operators are different. So that is called as reproducibility. Now in accuracy, there are 3 things that you should remember. There are many things, but I've kept things simple. These are all related to measurement devices, okay? One is called as a bias, one is called as linearity, one is called as stability. Let me give simple things first. Linearity. Suppose there is a, I'm weighing myself on the weighing scale, and for me, I'm between, say, 60 and 70 kg. So if I stand there, it will show a reading. Suppose if an elephant stands on that with one leg, do you think it will be able to show that reading? No, which means the scale, the weighing scale will show consistent reading only within a particular range. So beyond a particular, so this is called as a linearity errors. Bias means there is a true value, but then this consistently shows a deviation from the true value. For example, if I measure myself on a weighing scale, actually my true weight I saw in a ultimate very good measuring instrument is 60 kgs. But if I I go to a nearby gym, I measure myself, it shows 61 kgs. And anyone who stands on that, it shows 1 kg more. How many of you see vegetable vendors like that? They will always be some, something less, a few grams less, right? Vegetable vendors. Trick sometimes, yeah? Right? Some small, this is called as bias. The true weight is something different. And they always put some extra weight, magnet or something like that, just to make sure that they always sell you a little less, some 10 grams less or 50 grams less or whatever it is. No offense to any vendors or whatever, okay? But I'm just saying this for an example. But it has happened also. And finally, you find in the grocery store or in this thing, you find this is called as a bias, because bias is the deviation from the true value. Okay. Many people have had hard time understanding what a bias is. I can say that weighing scale has a bias of 50 grams because many people, I have done over 200 projects on Lean Six Sigma, okay, and many people still do not get exactly what bias means. Bias means they always think, a person's bias towards certain things. This is called as an equipment bias, measurement bias. Okay, stability is consistency over a period of time. In summer, winter, how it is behaving, right? And, shift A, shift B, over different time periods, how the instrument behaves. We will go deeper into this. So this is measurement system analysis. So in standard gauge and R, this gauge variation is called as repeatability, and variation due to the measurement procedure is called as a reproducibility. So I measured this part 1, part 2, part 3, part 4, and I measured this again for the second time, again for the third time. There is a repeatability issue because of this gauge. And because of the measurement procedure, I also measure and someone else also measure. And because the procedure slightly differs from person to person, slight tightness, slight looseness, or the way that you see, the angle with which you see the measurement procedure, there is a reproducibility issue. You're not able to reproduce. So which is operator to operator and operator to parts. Now, this slide and the next slide is little difficult to comprehend. Do not worry about that, but I want to give it to you all. And I want you to go through this video again and again to comprehend, okay, this phenomenon. Okay, so operator to operator, there is a variation, and operator to parts also, there is a variation. Me measuring this part, me measuring that part, and someone else measuring this part, and someone else measuring that part. Suppose there is something called, which most of the books do not talk about expanded gauge and R, but I want to give you the overview of this expanded gauge R. Okay. So linearity means with respect to a different range. How? Linearity means, this weighing scale is more or less okay to measure between 50, 40 to 80, but beyond 80, maybe it doesn't give. Okay, expanded gauge R&R, we spoke about variation due to the gauge and variation due to the measurement procedure, and variation due to gauge we called as repeatability, variation due to measurement procedure we call reproducibility. And you see within the gauge also there will be a variation. And gauge to gauge, there is a variation, because in companies, when they are measuring components, you will not have only one measurement device. A screw gauge is there, a linear vernier caliper is there, or a scale is there. They will not have only one instrument. There will be a lot of people who will be measuring, right? So within the gauge itself, there is be a variation. Gauge to gauge, there might be a variation. Today, you come and take this micrometer and you measure. Tomorrow, you take a different measurement instrument and measure. There will be a variation, right? Measurement instrument to measurement instrument, there might be. Part to gauge, there will be a variation. And this one we have seen, operator to operator, operator to parts, and operator. Why am I saying all this? When we are going to do a gauge R&R exercise, probably in the next class, okay? An example, we'll be using Minitab and seeing different components, which generally is not elaborated much in the books. And I wanted to explain in detail about this.